visiting us from California. He's going to tell us about some exciting wireless work that's going on out there. And the hope here is that this will also start the ball rolling big time here in the state of Maine. So this is a somewhat subversive talk, but it's all for a good cause. And so let's have a nice warm welcome for Dwayne.
Thank you. It's a pleasure to be here. It's the second time I've been to, well, actually the third time I've been to Maine. And the first two times were last year. So before, Maine to me was like the dark side of the moon. So I'm an entrepreneur from Silicon Valley, so I'm CEO of a company called the Dannon Group, and we're sort of a wireless ISP. We're a common carrier in the Kingdom of Tonga. We're doing wireless networks in Mongolia, so we're multinational, okay? I want to talk about sort of an adventure that's going on in California here. We have a group that runs the state educational networks called CNIC, the Corporation for Educational Networking Initiatives in California. And CNIC's been tasked by the state to do something called the Gigabit or Bust Initiative, which is to bring everybody in California, home and businesses, gigabit pipes, symmetric gigabit pipes by 2010. Okay? This is our JFK, we're going to go to the moon project. Okay? So as you know, California has a history of certain kinds of initiatives like our electric car initiative that have various degrees of success. So hopefully this one will be a bit more successful than that one. But I understand we're real serious about this, and we're actually in phase 3 of a 4-phase program to make this happen. Okay? So one of the reasons I'm here is to sort of evangelize you people here and get the state of Maine to join the initiative, because this really should be a national initiative and not just the state of California by itself, again. So I like to start my talks out with sort of a historical perspective, because what I find is that a lot of people don't know about the past in the ways that I want to focus on it, and it also helps to center us as we get into talk about current topics. Okay? And I want you to understand that this perspective is not, the talk I'm going to give is about the Gigabit Initiative, and the Gigabit Initiative is really wired and wireless, but I'm in charge of the wireless task force for CNIC, and so I'm going to focus on wireless, because a lot of people, you know about wires, but you don't know about wireless. Okay, so I'm going to tell you a lot of stuff about wireless that you've probably never heard before. But let's go back to the 19th century, the early 19th century. And before the telegraph, the fastest way that man could communicate was the fastest animal or the fastest wind-driven ship. Okay? So we tend to forget this because we've been living in a world since we were born that has light-speed connectivity. Okay? So we don't really think back to the time before light speed was available, so that what people had to do and how that world worked. Okay? But it's very important because it puts what we're doing, I think, in perspective. So here's my first premise. First comes the technology. And then, as time passes, it becomes more accessible. So it's the accessibility that really makes the technology common, as opposed to when it first appears. And sometimes, depending on the technology, that can be a short amount of time or a very long amount of time. And in the case of the technology we're talking about, it's actually been a long amount of time once you look at it from the perspective I'm going to present it. So if you look at the telegraph, like it appeared about in 1835, we went from foot speed to light speed. Okay? And if you look at how that impacted society, a historian by the name of Tom Standage has written a great book called The Victorian Internet. And as a quick read, I encourage you to go read it, because he looks at the writings of the time and what people had to think about in terms of this world now that was like, you know, had light-speed communications and how it impacted the society. I have a bill that was introduced in Congress in 1854 that proposed building a transcontinental telegraph that was going to be buried a couple feet under the ground all the way across the country. Okay? And it talks about the word count that would be given to the government as part of a subsidy for getting the land necessary for the right-of-way for this telegraph. 1854. And if you read this bill, you know, if you didn't see 1854 in the 12th Congress, or you know, whatever it was, okay, you'd think this was talking about today, okay, if you read this bill. in terms of the way the words flow and everything, and information highway is used, okay? And you say, wow. So we share a lot of common aspects with our people, our colleagues back in the 19th century in regards to technology, okay, in terms of how it impacts society. So again, if you don't look at this from a historical perspective, you never really, you don't dig this stuff up. So to me, it helped put the internet in a better perspective, okay, today. So if you look at the early wireheads, here's an early telegrapher, okay, it was until Marconi that the different technology or different manifestation of light speed manifested itself, okay? So Marconi did the first transatlantic signal from Newfoundland to Cornwall, England in 1901, okay, this didn't come out because I shift the perspective. Basically, the first commercial service that Marconi did between the United States and Europe started in 1903. So we're like at the 100th anniversary last year of that service, okay? So now if you look at early wireless heads, here's a ship at sea that had been equipped with wireless telegraphy equipment, okay? Now, if you look at the amount of time it took that to happen, okay, this basically represents a ship. So he's doing commercial service in 1903, and you had a lot of ships at sea equipped with wireless equipment by 1908. Okay, tremendous uptake. So you see that when there's a technology out there that people want and makes economic sense, it gets adopted. Okay. So at that time, the radio spectrum was treated as an open commons. Okay, because that's what it was. I mean, you send a signal and you didn't worry about anybody else, and there wasn't a lot of control. You just sent, and it was like a common bit of like the Boston Commons. Everybody sort of shared that the spectrum because the radio equipment at the time wasn't very selective. But that changed after the Titanic disaster, which was April 1912. And you've all heard about that and how wireless telegraphy figured in that event. Okay? So the impact of that was that interference in the radio spectrum became an issue, and this led to the formation of the Federal Communications Commission in 1934. There were some instances before that, but basically governments all around the world stepped in and said, we got to regulate this thing. Okay? So spectrum was locked into a property model as a result. So we went from this commons to a property model, and we've stayed there ever since. So essentially what was adopted in the Communications Act of 1934 was a 19th century view of spectrum, okay? In that it actually has some very interesting properties that make it not like land, but it's being treated like land. And this is an important thing to remember because it permeates thinking both on a policy level and an engineering level. So today, I want to talk about amateur radio for a minute because we're going the historical thing, because amateur radio started back at the time of the Titanic and all that stuff where people were, using the equipment themselves. So in the typical ham shack, I got my ham license when I was 12, and I had something like this. This is a Russian amateur radio operator. But amateur radio is a pervasive hobby, and it's all over the place, okay? So you have hams at the North Pole, hams in space, it's the International Space Station, and hams are all ages, okay? So what we learned from this experience with the amateur radio service, which is coming on 100 years, well, it's not 100 years, but close, is that hams did a lot of innovation in communications. Packet radio started in 1981. It was based on R&D that was done by DARPA, okay? And hams, essentially, what the innovation they did was they made it cheap, inexpensive. So they came out with a device called a TNC, terminal node controller, that you would connect a computer and a radio to, and it would do everything else. And it was called digipeating. So it essentially had a mesh network algorithm that was built into this thing, and it was self-governing. So it would self-manage itself. This was all in the early 80s. I said dynamic routing, and what hams did is they pushed modem development, and so by 86 we had 56 kilobit radios, which wasn't the case, in the wired world at the time. All right. So, hams also developed global packet radio networks using two protocols, AX.25, which is a modified X.25 protocol, and TCP/IP. And these networks exist today in that basically we have our own satellites, which you probably don't know about. We use HF radio in our own satellites to go across the water, okay? And we support emergencies in that when the regular infrastructure goes down, the amateur radio, packet radio networks come into play, and they work, okay? So this is little known by the general community, but I think it's important because it shows you, because what I'm going to get into here are existence proofs, okay? You know, that is like something happens and you can't, you know, it's there to go see. Because what happens a lot is you hear things, but you don't experience them yourself. So I'm telling you this stuff existed, anyway, we're seeing some changes now. So we had mesh networks in place by 91, and man's connected by the wired internet by 1995. In that, we basically had these radio clouds that covered cities, and we used the wired internet to connect them all the way around the world, and that's what's in place today. So what the service showed was that wireless networks can be built in a cooperative manner where the whole is greater than the sum of the parts, and that nobody owns the whole infrastructure. It's like the internet, independently owned and operated networks that agree to peer with each other using a common protocol or language. We showed that a spectrum commons can work through the adoption of simple rules because hams have no right to kick another ham off the spectrum. So hams actually have a lot of spectrum that we can use as long as we don't use it for commercial purposes. A lot of people aren't aware of how much spectrum we have, but it's a lot, okay? Thousands of megahertz, okay, up and down the radio spectrum, okay? So a lot of us do various things with that spectrum, and that's how communications art's been developed, by the use of the spectrum in very innovative ways. So it shows, finally, that innovation occurs when it's driven by needs, okay? Innovation occurs when it's driven by needs. So Wi-Fi arrives, and now everybody becomes a ham. Because with that little device there, you essentially are now tied into what we've been doing for 20 years, okay? Except you don't need a license to do it, and there's no commercial use restriction, okay? So what we're seeing happen now is that, now that you guys are getting these things, is that a lot more people, remember what I said initially at the start of the talk? The technology becomes available, and then its impact comes when it's more accessible, okay? So we've turned a corner now where wireless is available to the common man, where it really wasn't before. I mean, you guys use wireless like television sets and stuff, but wireless remains the one technology that you use it, but you don't know how it works. It's magic. And if you remember Clarke's third law, any sufficiently advanced technology is indistinguishable from magic, okay? And even practitioners of the craft like myself, there's disputes about how wireless really works, okay? And it continues to astound us by operating and manifesting itself in unpredictable ways. So it's the closest technology we've got to magic, all right? So that's important to remember. But now, because of this development, you're all sort of becoming magicians. And what's happening is that you are doing stuff with this technology that professional practitioners never dreamed was possible, okay? So innovation is driven by necessity. So if you look at what happened on a regulatory framework, the FCC started this road of unlicensed back in 1981. They put out a notice of inquiry to change the way that the government managed spectrum. And that this notice of inquiry, and hardly nobody knows about this, basically the FCC proposed to go back to a spectrum commons, okay? They proposed using spread spectrum technology, which had been developed by the military to do secure, unjammable communications. They wanted to get it out of the military and move it into the commercial sector. So they proposed using spread spectrum over the entire radio spectrum, okay, with no power limits. And the idea was that with spread spectrum, you could overlay existing services. You could overlay television signals, and it wouldn't cause interference. It wouldn't cause any harm. So where the government had to step in after the Titanic disaster, okay, the technology had now come and evolved to a point where it could essentially operate in a commons mode, okay? Very important. So the government had the science to back this up, because our government wasn't crazy. I mean, so that, proposing that we would go to this spectrum was a pretty risky thing at the time, but it was borne out by what the military had been doing for a long time with these technologies. So, and 4 years later, a report and order came out with the spread spectrum rules that we know today, with these 3 little bands and the 1 watt power limit. Now, what happened in those 4 years was a monumental, titanic battle between various forces, because there were parts of the government that didn't want this to happen, and there were parts of industry that didn't want this to happen. Okay? So, like the National Association of Broadcasters, because think about it, they basically felt the TV channels were their property. And now think about it, with this new technology, we could all refarm that technology and use it at the same time. So you can figure out why they were opposed to this. So it died. Okay? And it's unfortunate because we lost something. We lost 20 years because the science supported this. We could have done this 20 years ago. So we've lost 20 years in terms of evolution of the wireless. Okay? And that's very important to remember, because I'll bring it up again later. So we lost 20 years, but even so, we got something with these spread spectrum rules. And so the first equipment that got certified came out in '87. And it was data devices and stuff. And then other countries jumped on the bandwagon, because other countries, developing countries, had a need for infrastructure. So a lot of this unlicensed gear didn't come here into the United States. It was shipped overseas. Big time. Okay? There's a lot of it still deployed. And then about 1989, the 802.11 committee was formed to do home local area networking. This one didn't make it. But okay, so about 10 years. No, I don't break the flow. I'll fix it later when I send you a copy. But when we did that last change, that screwed this up. Okay. So hopefully it's only these certain slides. Okay. So 10 years after that, we saw the 802.11 standard appear. It took a long time for that standards process to gel. The Commission in 1997 allocated more spectrum. They created a service called the Unlicensed National Information Infrastructure Band. And they gave it 300 megahertz. Think of that crazy name, Unlicensed National Information Infrastructure Band. The purpose of this spectrum was to be used to do community networking, okay? To do point-to-point and point-to-multipoint links, okay? That's what Apple started this, and that was what it was for, community networking, pure and simple. And think about this. The cellular systems, those guys only had 200 megahertz of spectrum. So here's the government giving unlicensed, for free, 300 megahertz of spectrum. Okay? So there were some really interesting political things going on behind the scenes on this. Okay? And what I want to get you, again, you all learned the politics, but there were some cataclysmic forces behind the scenes going at this. Okay? 200 for cell, 300 for unlicensed at that point. Now, if you add the other unlicensed spectrum that was already there, you're talking about, at least 2 times what the cell carriers had, okay, in '97. Okay, Wi-Fi finally appears because the first 802.11 was only 2 megabits, and then the 802.11b was 11, as we know. And then something called SuperFi appeared, okay? SuperFi is what I call enhanced Wi-Fi, because the standard litany is that Wi-Fi can only go 300 feet. It's a local area networking technology. Well, what people did is they took it outside, and they started doing 30 miles, 40 miles, 50 miles, and beyond. Okay? I think the distance record for Wi-Fi right now is something like 265 miles or something like that. Okay? So this should not astound anybody that knows the science, okay, about energy and free space. But again, to the common people, this is miracle stuff. This, again, any sufficiently advanced technology is indistinguishable from magic. Okay. So the efforts of the NAB and the forces of darkness, okay, to kill this, as you can see, were unsuccessful in that they didn't think this was possible. They thought if they limited the power to 1 watt, how far can 1 watt go? So then 802.11 appears, and now we're moving from 11 megabits to 54, and then there's turbo modes for that. So like basically you're seeing anywhere from 100 to 150 megabits shipped today for Wi-Fi. Not standard, but anyway, you can get it. So gigabit or bust. I need to resize this because it's not going to work. So excuse me for a second. There we go. Okay, and then what got cut off was 802.16 or WiMAX appears, which will go 70 megabits at 30 miles. But SuperFi, I forgot to finish my definition of SuperFi is enhanced Wi-Fi plus proprietary wireless solutions. There actually are hundreds of wireless manufacturers that are doing proprietary wireless products, okay, that if you look, you find. But anyway, what's happened is that in the unlicensed spectrum, you've got tremendous innovation going on, okay? You've got companies saying, hey, I'm going to go raise money. I got an idea that I think is better than the standard, and I'm willing to risk it in the market to see whether or not there's a market for this technology, okay? So people are rolling the dice, and you, the consumer, benefit from this, okay, because you have a lot of choice. But what it also means is that you've got product cycles now that product development takes about 6 months, and product lives are like 18 months. We're into a consumer, mass-produced market space, okay? So you've got to reset your thinking about infrastructure, wireless infrastructure, because essentially it's turning very quickly. At IEEE 802 standards meeting just a couple weeks ago, a company put down a 500 megabit standard. So you'll see this in silicon 2 years from now, okay? So as you'll see, when I start talking about our initiative to get a gigabit by 2010, you can see we're on the path to have cheap gigabit radios by 2010. So the California Gigabit Bus Initiative is run by CENIC, which is the Corporation for Educational Networking Initiatives in California. It administers all the state broadband networks. The goal of the initiative, essentially, the state gave CENIC $2 million to get this thing started, okay? Because the CENIC incorporates all, like your regional network here, all the heavy-duty thinkers in networking in the state looked at this and said, look, right now we're shipping in laptops gigabit Ethernet interfaces, okay? I mean, it's consumer price gigabit, and we're getting ready to move to 10 gigabit, okay? So it doesn't make any sense, if you look at what the commercial players are offering, that it doesn't make any sense in that we're running these backbones like, you know, Abilene, and we're talking about the National Rail to go to 40 gigabits, that the consumer is running like, you know, like the FCC definition of broadband is 200 kilobits, okay? So we said we got to, you know, take command here and bring some logic and sense into this whole process, okay? So we shaped this vision, and we offered to the state, and we went through the whole political battle, like, what do you want to use a gigabit for? What are you going to do with that? You guys are crazy. So we went through that whole thing, you know, and I think we settled that in the state, and we're, as you'll see, we're into phase 3 of a 4-phase program. But anyway, it's important to understand that gigabit is not so much the data rate itself, okay? It's not a technology. It's about capabilities. It's about delivering capacity to do new kinds of applications. So, started in June 2002. As you can see, we're in the middle of phase 3. Phase 3 is let's figure out how we're going to do this and pay for it and all that stuff and who the players are and yada, yada, yada. And phase 4 starts in January, and that's where we start our implementation phase. We already have towns in California that have gigabit connectivity. So we have this sort of, and we've been joined by a group in the UK, the Access to Broadband campaign. They've adopted this gigabit initiative there. So they're beating on their government saying, hey, you know, let's do this. because these crazy Californians are doing it, and they're the 6th largest economy in the world. Okay. So we have a sort of a pragmatic approach to this. We came up with an awards program because look at Lindbergh. I mean, there was this thing, the Ortiz Prize, you know, and now there's the X Prize for the rocket ship stuff, spaceship. And so we have this awards program, and it started in 2003, and it's on the road to the Gigabit Awards. And so the idea is to pick projects in the state that show that we're stepping on this road to the gigabit. My company won the first year for a project that was funded by NSF that was operative on tribal Indian lands to put advanced network infrastructure down, so advanced wireless. So we basically were able to use tribal sovereignty over spectrum to deploy equipment that we couldn't deploy in the U.S. proper, okay, that gave the Indians infrastructure that makes us look like cave people in comparison. So we took stuff that was legal from Motorola, deployed it on the several tribes in Montana and North Dakota, and it's still there working. Now it's legal, but at the time it wasn't. And so that's how we do this thing pragmatically. And so my company won the award for this Motorola canopy system in that there's a utility company in Northern California called East Bay MUD. MUD stands for Municipal Utility District. And they had a licensed microwave network for their critical infrastructure, okay? Their utility, so they have all this data, dams and other things, you know, pumps and whatever. So this is one of their towers, and this is their 10-foot dish, okay? This is part of their old licensed microwave system. This is the Motorola canopy system, okay? Look at that. Picture's worth 1,000 words, and that shows you the difference between the technology, because essentially the radios that are driving this are just 10 years behind this, okay? But as I said, that you're not seeing the kind of rate of innovation and change in the licensed radio space as you're seeing in unlicensed. And so this radio is a 20 megabit radio, and this was basically a T1 kind of radio, okay? This link here was going 35 miles. This radio did the same distance with less power, a lot less power, okay? This is a 2-foot dish right there. This whole structure here weighs 6 pounds, as opposed to you need a crane to get this in place. That's the difference in the technology and the rate of innovation, okay? And as the technology changes, you don't have to change this dish out anymore. You can just replace this unit right here, okay? And that's it. So you still have to go up the tower, but you don't have to drag the stuff up and okay, here's another view of it. So again, look, right? Same path, 35 miles. But here's the thing, you know, it's like this is going 35 miles unlicensed, 35 miles. So WiMAX is supposed to go 30 miles. Well, what are we waiting for? I mean, we got this today. This radio costs $1,500 retail. Okay? So, conclusion, yes?
Who is paying for, I mean, right now I know it's R&D, but in the long run, when it's completely available, who's going to pay for the infrastructure of these guys all over the place?
You will.
Yeah, but I mean, how?
Well, I'll get to that.
Oh, okay.
So, what we've seen with unlicensed is that, just like amateur radio, wireless networks can be built in a cooperative manner where the whole is greater than the sum of the parts. And spectrum as a commons, with simple rules, works. Okay? And that everybody was predicting, you know, the engineers and stuff, that this whole thing would melt down. Okay? And more of this equipment is being dumped in the bands, and you know what? It just works because it's a Darwinian soup. It's survival of the fittest. So what you do as a user is you go out and buy the best radio you can with the bucks you got, you know, and you use it, and when it doesn't work anymore, you go out and buy the next thing, you know, just like a consumer product, okay? You read consumer reports, you say, okay, this is it, right? That's what's going on. So again, innovation occurs when it's driven by needs. So what I want to do now is just show you some of the things that's going on in the license in California. These are real on-the-ground projects that I have direct experience with. So usually when you go to talks like this, somebody tells you about something that they heard about. Okay? So I could do that, but what I decided to do, because I gave this part of the presentation at the FCC, I want to say, this is stuff I've actually, had my hands on. This works. This is real. So let's talk about an NSF-funded project, the High Performance Wireless Research and Education Network. It's funded by NSF, 2002, and some of you guys know Hans Werner Braun's the project, the PI for this project. And so basically you got people in the Internet 2 community who are not radio people. And the idea of here was to go out and sort of do a best practices kind of thing. So essentially come up with a wireless Internet 2 kind of network, delivering Internet 2 kind of connectivity, okay, over a very large area, okay, with off-the-shelf stuff. That was their mission, okay? So like I said, it represents best practices for Part 15. There's the URL for them. Here's the current coverage map. Now, it may be a little hard to see, but here is this part of California that's being covered by this network, okay? Now, the thing is, who'd have thought that you'd be able to do this? And this is an internet kind of, this is the backbone. These red lines are the 45 megabit at minimum backbone. This is Nevada over here, okay? All right? So, again, a picture's worth 1,000 words, right? So this has grown up. So this thing, and they're using all different types of wireless technologies. And here's, to give you an idea of how important this network has become. Some of you heard we had some big fires down in Southern California here recently, okay? Well, Hans Werner was asked to provide wireless connectivity to the Fire Incident Command Center, okay, which was out in the middle of nowhere, because the standard service providers couldn't provide the infrastructure, okay? So he was asked in the middle of the night to basically go up and take a link off his backbone, okay, and run it. Essentially, he had to go through 2 repeaters to get to the Incident Command Center. He did this at night with his team, okay? Now, I found out about this because the Internet Crew Group is getting ready to form a working group for high-performance wireless. And so we were having a planning call with various people for this meeting that was in, I think, somewhere in Columbus a week or so ago. And so I was on the call, and we had people come on, and we got the same old stuff about wireless. It doesn't work in the wet and rain, and there's interference, and yada, 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 from these wire heads. Okay. So Hans Werner was on the call, and he says, I may have to get off the call because we're supporting the fire thing, and I think I heard that there's a problem with the link. So he got a call, and then he came back and said, I got to go fix the link. So he goes off, okay? So we found out later that it was just a short, glitch and that everything worked. But, when he got off the call, I said to the people on the call, look, I don't want to hear anything more from you guys about interference and, all this other garble-farb, because listen to what you just heard here. We got these fires in California, and they're asking for Hans Werner to provide critical internet connectivity to the Fire Incident Command Center. Now, if that doesn't tell you where unlicensed wireless is, I don't know what else will. Okay? So, instant infrastructure is what you can do, and it's essentially user-provided infrastructure. Okay? And that's where the technology is. So, HP Ren today represents, I think, one of the best practices about how to do this stuff, particularly for the people in this community that are interested in high-performance networking. Okay? Again, all with off-the-shelf stuff. I want to talk about another thing, SoCal Freenet. This is a joint community networking project done by people in San Diego, Pasadena, and Orange County. Now, that covers a lot of geography there, you think? Okay. So what these people are doing are putting a wireless SuperFi cloud over those areas. Okay. It's a volunteer-driven effort, but it's part of this whole open source, open software community. Open source, open hardware, in that they're developing their own access points that have unique capabilities for what they're doing, and that they can't buy this stuff off the shelf. So what they do is they take OEM stuff, or regular off-the-shelf parts, and they add secret sauce. They add their own special software, okay, and they basically configure this stuff like I showed you in that video, okay, and they come up with price points which are lower for this stuff than from regular commercial vendors, Okay? And the thing about this is they share all this information with all the other people doing the same type of stuff all around the world. So what you have here is a new phenomenon where people are working together around the globe to develop first-mile communications infrastructure that's user-owned and provided. Okay? Yes?
I see the backbone part now. The first mile part, is that, what kind of antenna?
There's all kind of stuff. It's just, okay? We don't have the canopy, the thing that's like, you saw that 2-foot dish, but you can operate canopy. A lot of these devices have the canopy, the antenna integrated, so you don't see any antenna like you think of conventionally. Okay?
But I mean, like, to a laptop.
Yeah?
What is the laptop?
Well, the laptop will use some variant of 802.11. Okay?
And what is it connected
It connects to something else, a SuperFi hub. Okay.
So the SuperFi hubs with antennas that are basically omnidirectional.
Or no, it depends. It depends on what you're trying to do. Okay? Yeah. But yeah, it could be a star architecture. It could be different architectures. Okay? So I have a pointer there to SoCal FreeNet. Go check them out. Okay? So I want to shift to Northern California. Okay? SFLAN. Now, they've been around for a little over, I think, almost 3 years now. It's another community effort. They basically have an AUP, acceptable use policy, that says they're going to deliver symmetric links, no asymmetry. They want to be able to stream DVD quality video. So essentially that means they're delivering everybody in the network 5 megabit connectivity. So there's basically no restrictions in that. There's no, like, the cable networks and all this stuff. You can do whatever you want to. You get a real IP address, rock and roll. Okay? And there's distributed ownership of nodes. All for one, one for all. You route my traffic, I route your traffic. Now, they've done something interesting compared to the other groups. So here's their current coverage map. So basically they have some mountaintop sites because San Francisco's sort of that way. So basically, you go to their site if you want to get on the part of the network, type in your address, and it tells you what angle you have to point your antenna, directional antenna at, to get to the nearest node. You go out and do that, you're on. It's that simple. So they cover this part of San Francisco. There's a little spotty coverage over here and over here. They've got a link now going across the Bay to Berkeley. Okay. Various people are donating the internet bandwidth for this. Some big players like Amazon.com. Okay. They got a big pipe in there. They have something called the Internet Archive at the Presidio, and so bandwidth's not a problem. So, like I said, it was a meeting where one of the key people in this network was talking about it, and there were some really experienced network people running this thing, and he said something was really astounding to me. They haven't dropped a packet on this thing for a year and a half. Okay, so it shows you that with best practices, and you've got people who know what they're doing. They can, with the equipment that's available, you can put rock-solid networks together, and I think Hans Werner's effort has shown that too.
What are the X's that say?
Those are POPs. So what people do is that the mountaintop stuff, you go down here, and then people redistribute it from there. So they sip it off the mountain, and then they redistribute it in their neighborhood, and that's how it's growing. So if you heard of Larry Lessig, the attorney, okay, he runs a POP, and so he redistributes the stuff around his neighborhood. Okay. They set up an organization called the Bay Area Wireless Research Network, okay, and essentially this is an adjunct to SFLAN, and they do the hardware-software development for SFLAN. So this is a different type of approach where you saw the SoCal FreeNet, it's all jumbled together. So they've taken this approach. So again, they make all of this information available to anybody else in the world. It's open source, open hardware. Bay Area Network Coordination. Okay, my company's a wireless ISP in the Bay Area, and what we've done is all the ISPs, essentially, not all, but the major ones, have bonded together in this group, and we're coordinating our use of unlicensed spectrum. So instead of having thermonuclear war between us as competitors, we decided to sort of work together. And so when we put up a link, we sort of coordinate it with everybody else so that everything sort of works. This was the first time this has happened that we know about, I think you'll see this model being perpetuated in other parts of the country. So we coordinate the uniband, but we don't coordinate 2.4. We don't do that because we're all using 2.4 to get to our end users, like the first mile, okay? And we use 5 gig for our backbone links, okay? So my company, we have, yes?
Another economic question. Since you're coordinating all this stuff, does that mean that somebody could be, the money could be going a different direction than the radio signal? You know, in other words, they're sending it to you and you're over there, but they're actually using the Sky broadband?
No. We're just coordinating links, point-to-point links.
Yeah, but you know, when you have an ISP,
Yeah,
you sign up with them and you have a link to them.
yeah.
Okay, does that link necessarily go to your company? Or does
No. We all have our own independently operated networks, okay? And we just coordinate our point-to-point links that we're running our backbones over. And so we have our customer, everybody has their own different customers. So we're trying to avoid interference. Got it?
So still the ISP is a local.
It's your classic ISP model, you know.
Okay, it's local and they go by radio to you, and then if you're.
No. I want to move on. Okay. So this is working okay so far, but now I want to talk about something: the arrival of the municipal zone, hot zone, where essentially what's happening is that Wi-Fi superfly clouds are being built over cities now. Okay, you've probably heard about it. I mean, it's happening a lot in California. It's probably not happening much here in this state, but you know.
Not yet.
You either have private or public ownership. You can have multiple clouds. So the city of LA is thinking about doing this, but there's already, you know, free nets over that area. San Francisco is sort of toying with the idea. El Cerritos, California's got one over it. You know, Grand Haven, Michigan just announced one last week. Atlanta's doing it. Okay. New York City's doing it. Okay. So it's growing, and the thing is, it's like 2 years ago, if you talked to anybody about doing this, they would have locked you up, okay, because they just didn't think it was possible. But what's happened now is that there have been enough existence proofs out there to show that this stuff works, okay. So here's what it creates in terms. So this site here tracks all this stuff, munywireless.com. So go look at it. I mean, you'll be amazed that it tracks it globally. This is a global phenomenon. So you're getting a situation where cities now are providing telecom infrastructure which competes with the cable companies and the telcos, okay, and the cell carriers, okay. Now, some states have laws in the books that don't allow cities to provide telecom services. There's about 19 states that have these laws in the books. I don't know where your state stands on this, okay. All right. So the telcos or the incumbents aren't going to just roll back and lay back and let this happen. But it's happening because the economics argue to this. Okay, it works, and you're seeing amazing things like public safety, like in San Mateo, California. The police department's got Wi-Fi in their cars, and that's how they're doing all their mug shots and license plate checks and stuff over this Wi-Fi network. And like I said, if you had talked about this a couple years ago as being a possibility, you would have been locked up. Okay? But they're doing this. There's a town in Yakima County, Washington, that's been doing it for 4 years. Okay? So again, this just hasn't happened overnight. I mean, there's been, again, existence proofs longstanding that have gotten that public safety community to start moving in this direction. Okay? But, you reach a tipping point, and all of a sudden it's like, why aren't we doing this, is what happens. Okay? So, the conclusions here, again, is that you can build these things in a cooperative manner where the whole's greater than the sum of the parts. Contrary to many expectations, the networks perform good enough. So if you look at it from a perspective of a radio engineer, you say, this can't work. There's going to be too much interference. It's going to melt down. It's going to this. It's going to that. But you know what? It works good enough. Because you've got, like the ham radio thing, you're all hams now. You're all magicians. And you're figuring out ways to do this stuff, and you're adding more knowledge to the body of art for wireless communications, okay? More eyeballs. So it's essentially becoming what you're seeing in the open source, open hardware community now, okay? More eyeballs, more brains, instead of an old priesthood, okay? Which was what we had before. Innovation occurs when driven by needs. And the Spectrum Commons sort of works. So now we've got this big schism going because the government, remember, in '81 wanted to do this. And all the incumbents banded together and said, no, 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 it won't work. The airplanes will fall out of the sky and it will be the end of civilization as we know it. Well, they got the rules in '85 for this little experiment, okay? And here we are 20 years later, and you know what? They were right back in 1981, okay? So think about where we could have been today if the government's proposal had rolled, okay? It would be like Star Trek, okay? I don't know how else to describe it. Because look at what you're doing now, today, okay? Think about where you're going to be with this 2 years from now. It's hard to imagine, okay? Because things are changing that fast because we're in this consumer space where product development cycles are 6 months. Product lives are 18. So, I want to talk about some of the new devices you're going to start seeing here soon. We got things like mesh networking, smart radios, cognitive radios. So, smart radio, we started using these things as hams a while ago. So I've sort of, the thing about amateur radio is that as a ham, I can create instant infrastructure. Okay, I got the equipment. It's like I've been used since a teenager to having this communications web that basically encompasses the entire planet. So I've been there for a long time now. You guys are just stepping into that. Okay, so I know what it's like and can be. So here's an example of what I carry as a ham. It's called a handy-talkie. And it's about this big. It costs $350. It's an example of a smart radio. It has a receiver that goes from 0.1 megahertz to 1.3 gigahertz. Multi-mode, so it can receive anything that's transmitting in that band. Okay? As a transmitter, it operates on 3 bands. Okay? And up to 5 watts of power. Okay, your Wi-Fi stuff is barely 100 milliwatts, okay? The FCC limits a Y, okay? So with these devices, and it's got an instruction manual as big as your leg, okay, in terms of how many pages. And it's a real complicated device. It's a smart radio. But this thing can receive 2 frequencies at the same time. It can do crossband repeating. It can do all kind of stuff. Now the reason I'm showing you this is that you're going to have something like this fairly soon, okay? You may not know what to do with it now, but the thing is that it will do lots of stuff for you automatically, and I'll show you how that's going to work. But I wanted to show you, here's the existing proof of what is around today for consumer prices. Mesh networking. It's an alternative to star architectures. Example, peer-to-peer, ad hoc networking. Now, what I've seen is that in Europe, I just was over there about a month ago, and they, by regulations, can only use 1/10 of the power that we use here in the United States. So they wanted to do wireless, so they were forced into doing mesh architecture because they can't shout like we do, okay? Because we, like I did 10 times the power. So they've really advanced with mesh a lot. So I was at a conference in Berlin, and I saw something there which was truly amazing, this thing called the Mesh Cube. This is an open hardware kind of device. This is a 3x3 cube. Okay, it runs Linux, and it runs this open source code that's been developed by this whole EU community, open source community. Lots of brains, lots of fingers. Okay, and there were like about 250 of us at this conference in Berlin. What they did is they blanketed this part of Berlin, it was East Berlin, what was East Berlin, with this stuff. So you could go out and roam around and with your Wi-Fi laptop and get access to the net. So we were beating this thing pretty heavy, and I was making VoIP calls back to the States here that if I didn't tell people I was in Berlin connected with my Wi-Fi to the net, they wouldn't have known. There was no latency. It was just boom. I was impressed. Okay? So problems are being solved, and hardware is becoming available. So when I showed this in California, I got a number of people that are trying to order these things and bring them in the country. They haven't gotten FCC certification for this. Okay, but we can bring these in under the amateur radio rules. So I won't get into specs, but anyway, it can have 2 radio cards in it. Okay, so that's, so like it has 2 antenna things, so one can be doing this thing and one can be doing the local stuff, and the other one could be talking to the mesh. Okay, cheap. We'll get into the software. Okay, cognitive radio. It differs from a smart radio, and it operates heuristically or non-deterministically. I guess the best way to put this is, how many saw the movie 2001: A Space Odyssey? Remember the HAL 9000? That was a heuristic computer, okay? And well, yeah, I knew you were going to say that. Somebody says that when he's talking. But it has the ability to adapt and sense this environment. And IEEE just formed a standards group, 802.22, to look into the developing standards for cognitive radios. So this is not science fiction anymore, okay? And that the FCC has an outstanding rulemaking for cognitive radios, okay? What the commission is going to do is to decentralize their regulatory authority into the device. This is new stuff, guys. I mean, this is really paradigm-shifting stuff, because they realize this device is going to be in a better position to understand how to use the spectrum wherever it's deployed. Okay? So when all this sort of works out within the next few years, you're going to be having these things in your hands. Okay? And what it's going to do is that, like, you don't have to be a ham radio guy anymore and know all this stuff and pass tests, and that you'll just use it. And you can tell this thing, I want to communicate at a certain data rate to here, and it's another data rate to here, and it'll just figure out how to do that for you. Okay? Innovation at the edge. Okay? So, there's a project under the GNU, you guys know what the GNU is. Right. That's developing a cognitive radio. It's another open source, open hardware project. It's a peripheral device that will be connected to a PC. So you look at Moore's law on the PC side, more compute power than we know what to do with. Well, with a FireWire or a USB connection, you'll connect this universal peripheral device with an open API. That's what it looks like now. This will be shipping before the end of the year. And this is a radio thing. It's like it has these, you can put daughter cards on it, so you can put it anywhere you want in this radio spectrum. This is going to be a development platform for cognitive radio, because the industry guys like Motorola, Intel are not going to be developing this. It's going to come from these people. More eyes, more brains, more fingers. Okay? Because what, again, as I pointed out, is that you have a class of problem that a regular proprietary company can't solve, because you can only get so many brains under one roof. Okay? So this stuff is being developed. It's being made open. There's no IP issues and stuff. You know how the GNU works. Okay? So it's happening. So you can go find out about that. So what we're getting into, we just celebrated the 100th anniversary of the Wright brothers' first flight. We're there now, okay? Because, again, when I showed you earlier, it's like, look at the uptake between Marconi doing that first across the Atlantic, transmission to commercial service to wide-scale deployment. It can happen real fast. So what I'm telling you, okay, coming in from where we are with this gigabit initiative, is that you will have gigabit radios in the time frame I'm talking about. And they will be as cheap as the Wi-Fi devices you're playing around with now. So the question you have to face is, okay, this is going to come sweeping across the country, California. So what are you guys going to do? You going to sleep, or what? Okay? Or are you going to join the revolution? So, good enough is going to dominate user deployments. Okay? Or that term, good enough for government work. Okay? Systems evolution will track Moore's law. Now this brings into, what I'm getting into here is that your business models are going to have to change, because it's like the telecom guys are used to putting some sunk infrastructure in this to could stick around for 40 years or something like that. That ain't the case anymore, because all of this equipment is being driven by Moore's law, okay, particularly cognitive radios. Because you see, once we get to cognitive radios, they're going to be able to, standards won't matter anymore. They just won't, because the cognitive radio can take on whatever personality it needs to. So there's a big fight going on in the 802 group right now because, like the 802.16 guys, Intel, were trying to block the formation of 802.22. Because once it gets going, they're really dog food. Who cares what they do? Because they can whatever standard they come up with that can be subsumed in 802.22. Okay, so that's where we're going. Okay, so it won't matter because we'll be into a space now where again, lots of brains, lots of fingers. We're going to be developing new modulation techniques, new kind of stuff. Okay, that's what's going to happen. So gigabit will be here. We already got a proposal for 500 megabits, so you can see that track. We're 2 years for silicon on that. Okay, so it will happen. So what we need is sort of a best practices effort. We need to sort of start sharing this information better because there's more people coming under the tent. Okay, so I'm here from California, evangelizing you guys, saying, hey, look, here it is. It's real. You want to come to California, you can see it, or you can maybe move to some other state here and just walk, across the border and see what's going on there. Unity Wireless is happening. For good, bad, or indifferent reasons, it's happening, and it's going to cause cataclysmic things with the commercial infrastructure because, like, when the city's operating this network that it far exceeds the capacity in terms of throughput and whatever of the cable operator or the telco, well. And you have a choice as to what you use, and there's this free thing, and then there's this other thing you're paying through the leg for, through the nose. What are you going to do? Well, look, McKinsey just put out a study that showed that if you look at cell phone users, 80% of cell phone calls take place with the user being fixed or moving around at walking speeds. Okay, only 20% of the calls are done at car speeds. So that shows you that this kind of network, these fixed infrastructure networks, can handle 80% of the traffic that the cell guys got. So where's their business model? Okay? They're going to figure this out pretty soon because right now they're in denial mode because they don't think that you can do VoIP calls over Wi-Fi hotspots. Okay? But it's happening. I mean, I do it all the time. Okay? My laptop right here has a soft SIP phone in it, and I've been making VoIP calls over your network here. Okay? So how many of you have a soft SIP phone in something? Ah, there you go. Okay.
So we have some real mobile IP phones.
Okay, so you got those too. Okay, so you're going to see a device, an integrated device. You've seen these cell phones come out with cameras now and all this other stuff, organizers and whatever. You're going to see sort of like IP versions of this, and they're going to come from like you've seen there's cell phone and Wi-Fi devices out now from the regular incumbents, but you're going to see other kind of devices come out from the revolutionaries, okay, that are more like what I call generalized IP devices that have these capabilities. There are little companies doing like Pulver Innovations is one, and there's a whole slew of these guys that are coming out with these new kind of innovative devices. So the revolution's starting, guys, and I don't know how it's going to work out in our state. I know that we've got on our board of directors at Scenic, we've got SBC, and Verizon's there too. And they're telling us, oh, we're going to do fiber, and we're going to do fiber to the premise, and we're going to do da 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 da. And but then we've got cities like that are putting in this infrastructure, that's pretty damn good. So it's going to get real interesting here, real fast. I was called in by on Friday, before I came out here, to the San Francisco Public Utility Commission. Okay, they wanted to hire my company to put in a Bay Area wide area network for the utilities because they had dams and other resources all around the bay, outside of the city itself. Okay, and and they wanted to be their own independently operated network. This whole wide area that would cover like hundreds of square miles using unlicensed gear, because they heard about East Bay Mud and it was like, we got to do this because look at all the money. East Bay Mud's out there, at these utility conferences saying, hey, look at this, we're saving zillions of dollars and da. Okay, so now they've heard. Okay, so again, so I'm thinking like, wow, and then again, public safety, where they're using it in cars because Wi-Fi is not supposed to work in cars that are traveling at car speeds, but you know what? It does. You've got people that are flying in airplanes, that are using it, okay? So it works good enough. So the thing is, what's going to happen is this best practice information gets around as you guys, as the magicians, are going to start seeing this stuff do amazing things. But it really isn't amazing. Again, the government knew the science was there 20 years ago. Okay? So now we're playing catch-up. Okay? So it's another case where you can't keep saying the world is flat, and get away with it. Eventually, people figure out that the world's round. Okay? So if you look back historically, and this is my final word, paradigm shifts are ugly things. Okay? They can be bloody. They're never easy. We're in the midst of one. Who knows what's going to happen. Thank you very much.
Okay, there you go. Now, a couple of questions, and Dwayne is going to be here for a couple of days. One of the goals of his visit was to, give people an opportunity to talk to him, and so if you want to talk to him at greater length, let me know, and we'll work it into the schedule. But he's leaving Friday morning. On Wednesday, we're going to go down to Augusta. We've got a meeting set up with the Department of Economic Community Development. We're going to try to. Okay, why?
Because it's all Wi-Fi.
Okay, well, so is the campus. And I'm sure he's seen Wi-Fi.
Yeah, no, it's interesting. We went to the Civic Center to the city of Augusta and convinced them to let us put it in.
Okay.
And okay,
Oh, well, that's.
but that was 2 years ago.
Okay. All right. So anyway, are there any questions for Dwayne?
Yeah.
Yeah, innovation is the attacker's advantage and the defender's dilemma in this high-tech world. And I'm wondering who the new players are going to be, do you perceive? Are they going to be municipalities, or are they going to be entrepreneurial groups supporting municipalities, or what is going to be the substance of the new business model as far as who's the new players going to be? In the AT&T, Verizon, and Adelphia is going to continue protecting their
Well, they're doing that, and they're good at it.
defending their
But what's happening in San Francisco is that the city government's reaching out to the small entrepreneur, and the people are doing these things. And like SF Land, the city of San Francisco is talking about using it for public safety use because it's there and it works, and it's better than what's being delivered by the incumbents. So, and I think you're starting to see that all across the country, where you're getting this new kind of dialogue from the local government down to its people that you didn't see before, was always going up before.
I guess
Up and
my
out.
question is, are municipalities looking at this type of stuff now as basic road systems, as they did basic road systems?
Some are, some
We
aren't.
own the basic road systems in order to allow enterprise and communities to travel on.
Some are, some aren't. You got a lot of diversity across the country. Okay? That's what local governments and all that stuff is about, diversity. Yes?
Is there anybody putting on cable channels?
Yes?
And what is the model? Are they putting on one at a time? They buy them from the
Well,
or
like there's some of that going on in SF Land because they have the capability to do it. It's just sort of experimental at this point. Well, actually, there's certain well, let's face it. There's peer-to-peer file sharing of like BitTorrent and stuff, and so there's a lot of traffic doing that stuff over these networks. Okay, there's a lot of gaming doing because again, all gaming is about latency and low latency. So, okay.
What so this utopia of free networks, cheap, easy to build. What are the issues that are coming up in terms of protecting yourself? Someone's using your network, they're doing something illegal. How do you protect yourself from that?
People know how to do that. The security stuff is there, and if you can choose to use it or not. But Nicholas Negroponte, of MIT Media Lab, has an interesting model for this. He calls it the flower box model. So remember what a flower box is? You go down the street and you see these beautiful flower boxes that people maintain. Well, think of Wi-Fi or Superfi being the new flower box. Okay? So again, in this all for one for all kind of mindset, okay, that is what you're seeing, where people keep things open, okay, so that they can be shared by others. And I think you've seen this. You've all traveled. I was in London a while ago, and The hotel was charging me like, 10 pounds a night for internet access, and I said, screw this. And I opened my laptop and enabled it, and I found an open access point. I don't know where it was, but I used it. And you see this a lot now,
So do you not think, do you think that those implications have been well addressed at this point in time?
No, it's a shifting dynamic, okay? I mean, the people that care about security, they fix it, they know how to do it. The IEEE, 802.11i, which is the security standard for Wi-Fi, has been out there now. It'll be, so all that's being taken care of, okay? So security is just going to be it'll be removed as one of the fear, uncertainty, and doubt kinds of attacks that the incumbents make on this kind of stuff. Okay? Yes?
Have you seen anywhere across the country in your travels where communities or state government has got the equivalent of what corporations have, the chief technical officer?
Yes?
Really?
Yes?
Government?
Yes?
Do we have one here in the...
Well, there's a chief information officer at the state.
But it's really focused on internal state stuff, like
Okay.
your driver's license online and all that, not statewide.
And then, university has people concerned with communication and all that. Yeah.
Do you have any reason to think that these kinds of things would be more difficult to encourage in thinly populated areas? You show examples of really dense populations.
My company's starting a major deployment in Mongolia. That's as thin as it gets. We're using that as sort of we've also done Indian reservations here, which we can show you how that was done. So, no, this stuff, basically, what I'm here to tell you is that you can do 100 megabit infrastructure, and you can do as wide as area you need with existing off-the-shelf stuff, okay, at Wi-Fi prices. So that's not a problem anymore, as far as I'm concerned. What the problem is the aggregation issues, because when you start giving everybody 100 megabit links, then you have, where does the bandwidth come from upstream? Because people are running applications that use that bandwidth today. Okay? We're out of this. There's been all this cloaking by the cable industry and the incumbents, because I'm a member of the FCC Technological Advisory Council, we've been digging into this, and cable networks have gone reverse symmetric. I don't know if you know what that means. Basically, the idea was that there would be they're asymmetric in terms of architecture, and the idea is the user would just download stuff and they wouldn't be pushing stuff up very much. Well, because of these peer-to-peer technologies, what happens is that you grab a movie, okay, and it takes however amount of time it takes to download that. But the thing is, it's all for one and one for all. So as soon as you got the movie, you start sharing it, okay. So all of a sudden, the way these programs work is they fill up the upstream pipe, okay. So they're driving these asymmetric networks to the knees, and that's how they're reverse symmetric, because you keep sharing it for days, okay? So you get all these people doing this, and all of a sudden the networks which they had designed to be asymmetric are now reverse symmetric, So now they've got to mount these Gestapo tactics to try to, stomp these things out. But the problem is it's too widespread now, because they have to shut off everybody. You can't throw everybody into jail, okay? So that's the conundrum for these guys now.
On that happy note of
Okay.
throwing everybody in jail, maybe it's just a good place to stop. So let's give Dwayne another hand.
Thank you.